Hi everyone. Today we're starting with simple equation and my name is Ravi Prakash. Okay. Simple equation is a very important topic in algebra and in this quant, right? So simple equation doesn't mean only forming equations. We'll discuss lots of things in simple equation, right? Let me tell you what are things we'll discuss in simple equation. Okay. So in simple equation, first thing we'll discuss is condition for unique solution, and no solution. Okay. Second thing we'll discuss is forming equations. Okay. Third thing we'll discuss is reciprocal equations. Fourth thing we'll discuss is problems on digits. Right. And then we'll discuss it through lots of questions, right? Also we'll discuss this three equations and two variables cases, right? So these many things we'll discuss in simple equations with lots of questions. So this is very important topic I'll discuss. Maybe some people tease this in number system or in some textbook. You'll find this in other chapters, right? But all these topics are related to forming equations and solving equation, right? So we keep it under simple equation, right? So now let's start simple equation. Now see here, any equation of the form ax plus by is equal to c is called a linear equation or simple equation. Simple equation, right? Right? Degree is always 1. Degree of equation is 1. In quadratic equation, degree is 2. In cubic equation, degree is 3. Right? So degree is 1. What is degree? Degree is power. Power of variables. Let's say x and y here are variables. So power of x and y is 1. Then it is a simple equation. Okay. Graph of any simple equation, right? Graph of any simple equation or any linear equation, I should write, is always a straight line. Okay. So you can see here means first we'll see how to solve very simple equation or linear equation, right? So let's say one equation is a1x plus b1y is equal to c1 and other equation is a2x plus b2y is equal to c2. Now first equation I'm multiplying with b2, second equation I'm multiplying with b1 to solve it, right? How to solve linear equations? Just to make any term same and subtract it, right? If there are all plus signs here, simply you can subtract it. Okay, so now b1 b2y and b2 b1y becomes same, it can be cancelled. What you're left with a1 b2x minus a2 b1x is equal to c1 b2 minus c2 b1. It can be written as, or x is equal to c1 b2 minus c2 b1 divided by a1 b2 minus a2 b1, right? Now since this is a value of x, this denominator can never be equal to 0. Therefore I can write a1 b2 minus a2 b1 can never be equal to 0, right? It means that a1 by a2 cannot be equal to b1 by b2. Very important point, right? This is the condition, because if you solve like this, we'll get what? We'll get one value of x, and similarly if by putting this value of x in the equation, we'll get one value of y. This is the condition for unique solution. I'll get unique solution only when in two equations, this is equation 1, this is equation 2. In two equations, if a1 by a2 is not equal to b1 by b2, then only we will get the unique solution. Okay. Now, the other cases are, see, suppose if the case I write 2x plus 3y is equal to 5 is one equation, and 6x plus 9y is equal to 15 is another equation, right? Now if we try to solve it by equating y, I cannot solve this, right? Because you'll see both x and y will get cancelled. Why x and y will get cancelled? because ratio is same na. See, it is a1 is 2 and b1 is 3. Okay, a2 is 6 and b2 is 9. So you can see here a1 by a2 is equal to b1 by b2. So therefore there is a condition of what? There is a condition of no solution, right? This condition for unique, sorry, it's condition for not a unique solution, not a unique solution, right? So why? Because this you can see here, since a1 by a2 is equal to b1 by b2 and is equal to c1 by c2 also, because this is also 2 by 6 is 1 by 3, 3 by 9 is 1 by 3, and 5 by 15 is also 1 by 3, right? So is equal to c1 by c2 also. Okay, so if it is true, that means in this case we'll have infinite solutions. Why we'll have infinite solutions here? Why we'll have infinite solution here? It is because this equation 2 is nothing but a derivation from equation 1 only. See, equation 1, a1 by a2 is what? It is 3 times. So b1 by b2 is also 3, 1 by 3, and c1 by c2 is also 1 by 3, right? So this equation 2 is just equation 1 multiplied by 3. Equation 1 multiplied by 3 will give me equation 2. That means these two are same equations. These two are same equation. That means we have only one equation here. We don't have two equation here, because equation 2 is just equation 1 multiplied by 3. So we have only one equation here. We have only one equation here, right? That is 2x plus 3y equal to 5. We have only one equation. So 2x plus 3y is equal to 5. Since we have only one equation, so there's no constraint on x and y. So how many solutions? We'll keep on putting the values of x, and we'll keep on getting the values of y, right? So in this case, we have basically no solution. Okay. In this case, we have, sorry, not no solution. That means infinite solution. We'll keep on putting the value of x. Since we have single equation, we'll keep on putting the value of x, and we'll keep on getting the value of y without any constraint, right? So that's why infinite solution. Okay. Now third one is condition for no solution. See, similar equation 2x plus 3y is equal to 5, and let's say 6x plus 9y is equal to 10. So this equation 1, this equation 2. Now you can see here again will not have unique solution, because again a1 by a2 is equal to b1 by b2. So a1 by a2 is equal to b1 by b2. So it is not a case of unique solution, right? For unique solution, a1 by a2 should not be equal to b1 by b2. This is not a case of unique solution. Okay, fine. Now, is this equal to c1 by c2? No, because a1 by a2 and b1 by b2 are 1 by 3. This is 1 by 2. This is not equal to c1 by c2. This is not equal to c1 by c2, right? That means what? That means this is inconsistent equation. This is called inconsistent, right? Equation is inconsistent because since a1 by a2 equal to b1 by b2, that means it's like this is multiplied by 3. So if 2x plus 3y is equal to 5, and if it is multiplied by 3, that means 6x plus 9y is equal to 15. Okay, so 6x plus 9y should be equal to 15, but it is 10 only, right? That means in this equation 1 gives us that 6x plus 9y is equal to 15, but this equation is saying that 6x plus 9y is equal to 10. So at the same time, values cannot be same, right? 6x plus 9y cannot be 15 at the same time, and 6x plus 9y cannot be 10 at the same time. That means this is inconsistent. Values are inconsistent, right? So what is the case? This is a case of no solution. This is a case of no solution, right? So when you get no solution, when a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. Okay, is not equal to c1 by c2. Correct? Yeah. I hope it is fine. Okay. Now 3x plus py is equal to 17 and qx plus 8y is equal to 19. This equation 1, this equation 2. Okay. Find the number of pairs of p and q for which this equation will have no solution. This equation will have no solution. I should write these two equations. These equations these equations will have no solution. This is the question. Okay, this is the question. Now for I know for what is the condition for no solution? For no solution, a1 by a2 is equal to b1 by b2 should not be equal to c1 by c2. So anyway, c1 by c2 is here, like this is a1, this is a2, this is b1, this is b2, right? And this is c1, this is c2. So anyway, c1 by c2 is what? 17 by 19. These are two prime numbers. So any ratio a1 by a2 is 3 by something, and it is p by 8, right? What is a1 by a2 here? 3 by q. So a1 by a2 here is 3 by q is equal to p by 8. Anyway, since there are 3 and 8 here, anyway this cannot be equal to c1 by c2, right? Because it is 17 by 19. So how many solutions we got here? So we got, okay, p into q we got as 24. So p into q we got as 24. So 24 means how many solutions? 1 into 24, 2 into 12, 3 into 8, and 4 into 6. Okay, 4 into 6. Now, since we have been asked pairs, right, p and q here, so variables are given. That means it is ordered solution. Right? For ordered solution, always it is like, for ordered solution it is what? 1 comma 24 and 24 comma 1 will be different, right? But see here, in this case, since it is p and finding numbers of pairs of p and q, for which these equations will have no solution, and you can write here, just mention one more thing in question, p and q are integers. Right? Positive and negative not given. That means I have to take all the cases of positive and negative as well, right? So if it is 1 into 24, like any one value it takes, like it is 4 into 6, so it will have 4 values now. 4 comma 6, 6 comma 4 in ordered solution, minus 4 comma minus 6, and minus 6 comma minus 4. Okay, minus 6 comma minus 4, right? So one way writing p into q as 24 in one way will have 4 pairs of ordered solution if negative is also considered, right? So I can simply write here 4 pairs of ordered solution means what? There are total 4 pairs here. So how much? 4 into 4, that is 16. So we'll have 16 solutions for this question. 16 solutions for this question. Okay, 16 solutions. There's the answer, right? Simple. Condition for no solution is a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. This is 17 by 19, and here it is 3, here it is 8. So anyway, these are prime numbers, right? It cannot be broken up. So anyway, this cannot be equal to 3 and 8, right? 3 by something cannot be equal to 17 by 18. So we don't need to 17 by 19. So we don't need to consider that. Simple 3 by q is equal to p by 8. P into q is 24. There are 4 ways of writing. One way will give me 4 solutions in integral and ordered, right? Both combined. So integral and ordered 4 solutions. So total 4 into 4, 16 solutions. That is the answer. Correct? Okay. Now, next concept here. See, finding. Suppose I write a number here, or let me write a statement here. In a library, some books are kept. When books are bundled in groups of 11, okay, 4 is left out. Okay, 4 is left out. And when the books are bundled in groups of 9, let's say 1 is left out. So how to form equation here? So equation can be found by, so when books are bundled in groups of 11, 4 are left out, right? So I can write, let the number of books in library will be of the form. So books are bundled in groups of 11, right? So let's say 11, there are x groups. So 11 into x. And then 4 is left out. So that number should be of the form 11x plus 4. Okay. This is equal to Then the books are bundled in groups of 9, one is left out. Okay, so in groups of 9, so let's say 9, 9, 9, 9, I can form y bundles. So one is left out, so 9y plus 1. So then the number is of the form 11x plus 4 is equal to 9y plus 1. We have discussed so many such questions in numbers, right? Same thing here. A number when divided by 11, remainder is 4. So 11x plus 4. Same number when divided by 9, remainder is 1. So 9y plus 1, right? So what is my first such number satisfying this condition? We can solve it easily. We know how to solve it, right? We can solve it. See, 11x, always I can write 9y is equal to 11x plus 3, right? So I told you two ways this in remainders, how to find this, right? So once is by finding remainder, I can do remainders concept, and second simply by hit and trial. So since here it is equation, okay, I'm doing simple hit and trial only, you can find a remainder also. By putting x equal to, what I want is x and y should be integers. X and y should be integers, right? Because 11 books, I make x bundles, so there has to be an integral number of bundles, right? There can't be 3.5 bundles, right? So 9y is equal to 11x plus 3. Now let's put, we have to do some hit and trial here and check at what value of x I'll get y equal to 1. So at x equal to 1, I'll get 9y equal to 14. Y is not an integer. At x equal to 2, we'll get 9y is equal to 25. Again, y is not an integer. At x equal to 3, we get 9y is equal to 36. 11 into 3 plus 36. Here you get y as integer. Y is equal to 4. That means y equal to 4 satisfied. So either we'll put x equal to 3 or y equal to 4 in the original equation, and I'll get 9 into 4 plus 1. 37 is my number. 37 is my number, right? Now I told you numbers, another way to do it. We can do it like, I can bring both the variables to the left side. Okay, so we can write 11x minus 9y is equal to minus 3. Okay, and what it told method to remove this, remove the lower divisor. So among 11 and 9, 9 is the lower divisor. So how to remove lower divisor? Divide both side by 9 and take the remainder. Divide both side by 9 and take the remainder. That means basically what? So 9 by 9 remainder is 0. 11 by 9 remainder is 2. So it becomes 2x. So it's like 2x by 9 will give me a remainder of what? Will give me a remainder of minus 3. So when you'll get remainder of minus 3? When divisor is 9. So add 6. Add 6, right? Minus 3 when you'll get, because it is positive remainder on left hand side. So you also convert positive remainder to right hand side, right? We discussed this in remainders. And if you get negative remainder in left hand side, so you also get negative remainder in left hand side, right hand side, right? So 11 by 9 positive remainder is 2, so 2x by 9 remainder is 6, right? When you get minus 3, because 6 by 9 remainder is what? It is minus 3. It is minus 3. Okay, so 2x by 9 remainder is 6. So you can simply do here, at what value of x you'll get remainder as 6. So obviously at x equal to 3. Obviously at x equal to 3. So at x equal to 3 you'll get remainder as 6. That means x equal to 3 is a number which you're looking for. Okay. Okay. So x is equal to 3 is a number which will satisfy this. What will satisfy this? Because left hand side will be and right hand side will be equal. So at x equal to 3. So simply we'll put, see, we got x3 in here. We got x3 here. Okay. So if simply put x equal to 3 here, we'll get number as 37. So there are two ways of doing it. First way is hit and trial. Second way is by remainder method. Okay. Always remember, there are two ways of doing this, right? In complex questions, remainder method works very easily. We have shown this in remainders. Okay, we have seen this in remainders. Okay, so anyhow, the number is now what is the number? Number is 37. Number is 37. Okay, fine. Number is 37. Now again same thing, right? We discussed this earlier also. It is like first number here is 37. What is the next number? So next number should be LCM of divisors into k, right? That is 37 plus 11 and 9 are the divisors. So LCM of 11 and 9, that is 99. So 37 plus 99k. That number is of the form 37 plus 99k. We discussed why also, because if 99k is added in 37, I want all such numbers which when divided by 11 gives me a remainder of 4. So now if I divide this by 11, so 37 by 11 remainder is 4 and 99 by 11 remainder is 0. Okay, and if also I divide 37 plus 99k, if I divided by 9, then 37 by 9 remainder is 1. Okay, 37 by 9 remainder is 1. Okay, and 99 by 9 remainder is 0. So again remainder is 1 only. 4 plus 0 here is just 4, here it is 1. So adding something which won't affect the remainder, right? I want remainder to be always divided. All such numbers which when divided by 11 leaves a remainder of 4. So that number should be of the form 37 plus 99k, because it is 11 plus 9, 11 and 9, right? So I want that number here which will give me remainder 0 on dividing by 11 as well as 9. So that has to be there LCM, that is 99. That's why it is 37 plus 99k. Okay, so very important, right? Let me move to next slide. So it was like 11x plus 4 is equal to 9y plus 1. Okay, this equal to, and this is equal to 37 plus 99k. That number is of the form 37 plus 99k. Okay. Now here's a pattern here. You see there's a pattern here. 11x plus 4 is equal to 9y plus 1. Okay, there's a pattern here. What is the pattern here? Pattern here is, we got at x equal to, okay, first value, positive value of x is 3. So at x is equal to 3, we got y is equal to 4. And we got number as what? 37. Okay, that number is of the form 37 plus 99k. So that means number will every time increase by 99. So second number will be what? At k equal to 1, that is 136. What is next number? 235. Just keep on adding 99. I'll get all those numbers which when divided by 11 gives a remainder of 4, which when divided by 9 gives a remainder of 1, that is 335. Sorry, not 236 here, 235, and then 334, and so on. Now what about x and y? So you see here, x is equal to 3. Okay, so now the next value of x which you get here is directly you can write x will form an AP. Okay, let me form right here. Right, series of x will be an AP with common difference as coefficient of y. Right, very important. That means after x, so we go by hit and trial, we got x equal to 3. Now we don't need to do any hit and trial, right? After x equal to 3, the next number satisfying our condition, that means by putting x as some integral value, I should get y also as an integral value, right? That will be x will form an AP with common difference of coefficient of y, that is 9. So x will increase with 9. That means after 3, 12 is the number which if I put here will get coefficient, will get y as an integer, right? You can check here between 3 to 12 we won't get any number. Similarly for y, so you see if x equal to 12, so 11 into 12 plus 4, 136 minus 1, 135. So 9y is 135, so y is 15. You see y is 15. What is the difference in y? After 4 it is 15. What is the difference in y? 11. What is 11? Coefficient of x. So another important point. And series of y will be an AP with common difference as coefficient of x. Right, very important point, very important, these 2 points. Okay, so x is equal to, that means 3 and 12, and by putting, so x equal to 3 by 12 you get y equal to 15. And what is the number you got? If you put x12, what is the number? Number will be 136. Correct, fine. Now next number, after 3, 12, you add further 9. So what is 3 plus 12 plus 9? Again, sorry, 3 plus 9 is 12. Again further 9. It's an AP, right? It's an AP now. So what is 12 plus 9? 21. What is 15 plus, now it is 11, right? It is 11 now. What is 15 plus 11? 26. Okay. So by putting 21 and 26 here, by putting x as 21 or y as 26, what is the number? Number will be 235. You can see here, 21 into 11 plus 4, 235. So it goes like this. Okay. By x as 21, 26, 235. So very important point in a two variable equation. If the series is like this, right? X will increase with a coefficient of y as the common difference in an AP, and y will increase as the coefficient of x in an AP with common difference, right? As coefficient of x. So y will increase with a y will be in AP. Values of y will be in AP with common difference as coefficient of x. Values of x will be in AP with common difference as coefficient of y, that is 9. I can write this series here. I can write this x as 3 plus 9k. 3 plus 9k series. I can write y as 4 plus 11k series, because starting from 4, difference of 11, here starting from 3, difference of 9, so 9k, and number is of the form 37 plus 99k. 37 plus 99k, right? 3 important things we got here. Okay, so we'll continue this in next video. Okay, thank you.